Welcome to this explainer. Today, we are stepping into the director's chair. We're going to build a high-scoring strategy for the Cambridge AS and A-Level Information Technology 9626 exam, and we're specifically zeroing in on system software, compilers, interpreters, and linkers. But look, we aren't just going to read a textbook definition of what a compiler is. You already know that stuff. Instead, we are looking at the actual theoretical and technical architecture of how you are graded. We are going to build your blockbuster exam answer scene by scene. We're cutting all the fluff, cutting the filler, and keeping the action focused purely on the established principles of systemic analysis that Cambridge demands. Now, to really set the stage, I want you to picture two typical computer science students tackling a real Cambridge past paper question. Let's call them Alex and Sam. Alex is the overloader. Alex walks into the exam, sees the word compiler, and just vomits every single technical fact they've ever memorized onto the page. No analysis, no structure, just a massive wall of text. Then you have Sam. Sam is the rusher. Sam races against the clock, barely glances at the scenario, totally misses the command word requirements, and gives a generic two-sentence answer. On a split screen in front of you, you'd see both of their answers completely covered in red pen marks from the examiner. They both failed to secure the top marks, not because they didn't know the tech, but because they lacked a system. Today, we fix that.
Okay, let's take a look at this massive, glaring number on the screen, 15%. Did you know that Section 2.2 of your syllabus, System Software, Compilers, Interpreters, and Linkers, accounts for approximately 15% of your total marks in Paper 2? Let that sink in for a second. 15% is absolutely huge. That is not some tiny margin of error. That is literally the difference between an average grade and a top-tier standout grade. That's the difference between struggling to secure your desired university placement and confidently walking right into it. When we break down the specific assessment objectives for this topic, they target very distinct cognitive domains. Sure, they want knowledge and understanding, but more importantly, they are hunting for application and analysis. Alex and Sam lost their marks because they treated a 15% analytical section like a 1% vocabulary quiz. You absolutely cannot afford to just skim this section or rely on raw memorization. We need a targeted, bulletproof strategy.
And this quote right here brilliantly illustrates exactly what the examiner is actually looking for. The academic benchmarks require logical, structured reasoning. Achieving top marks means you need a structured, interconnected framework, not just a superficial, mile-wide, inch-deep breadth of knowledge. The principal examiner reports explicitly tell us, literally spell it out, that candidates who reference cross-topic connections achieve significantly higher marks. What does that actually mean for you in the exam hall? It means you can't just memorize what a linker does in total isolation. You need to understand its integration with other areas of the syllabus. You have to understand the causal relationships. For example, how does a compiler's output fundamentally dictate what the linker has to do? How does that chain reaction impact the overall system architecture of the final software? The assessment framework prioritizes analytical depth. They want to see that you understand the whole chessboard, not just how the individual pawns move.
So, to pivot your mindset from just memorizing facts to mastering this systematic approach, here is our game plan for today. 1. Examiner warnings. 2. The method mark strategy. 3. The procedural framework. 4. Comparative analysis. And 5. Evaluative thinking. Let's get straight into it.
First up, Section 1, the top 3 examiner warnings. Now, what's genuinely fascinating about these 3 specific warnings is that these mistakes have absolutely nothing to do with a lack of technical knowledge. It's entirely a lack of systematic reasoning. First, examiners constantly report that students confuse cause and effect. For instance, when explaining how an interpreter handles an error versus how a compiler does, candidates like our friend Alex often mix up the root cause of the system's behavior with the resulting effect on the user experience. Second, students completely forget format and presentation. You might have the right technical idea, but if you don't present it logically, the examiner simply cannot follow your evidence-based reasoning. Third, and honestly, this is the most fatal trap, providing answers that are not specific to the given context. If a question asks why a specific, fast-paced startup company should use an interpreter during their initial prototyping phase, writing down a generic textbook definition of an interpreter will score you almost nothing. You have to apply the concept to the scenario. Before we continue, subscribe to our YouTube channel, AC Exams, at @ACExams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, to solve these 3 errors, top students use the POL framework: point, evidence, explanation, link. You make your point about the software, you provide evidence from the exam prompt, you explain the technical mechanism, and you link it back to the question's core context.
So using that Peel framework, your very first step, your point, must always involve establishing precise definitions. The examiner reports are practically screaming at us that candidates confuse key terminology right out of the gate. Think back to Sam, who rushed the answer. Sam started arguing about execution speeds without ever explicitly defining what a compiler even is. You must define your terms strictly before you dive into an extended response. If you're comparing a compiler and a linker, define their distinct roles immediately in your opening sentence. A high-scoring theoretical architecture rests entirely on precise definitions. If your foundational terms are shaky or ambiguous, your entire analytical framework basically collapses in the eyes of the examiner. It's like trying to build a massive skyscraper on a foundation of mud. Define the tech, then analyze the tech.
Which brings us perfectly to Section 2, the method mark strategy. This right here is where the magic happens. In Cambridge IT and computer science exams, you are evaluated heavily on your systematic processing. This means marks are awarded for the process, not just your final conclusion. When you are analyzing system software, you need to encode these complex concepts logically and show your work. Let's do a live transformation right now. Imagine Alex wrote, "Compilers are better because they are faster." That gets 0 method marks. It's just a conclusion. Now let's guide Alex to rewrite this using our success blueprint. We take a red pen to that awful sentence, and we transform it into green check marks. Alex now writes, "Compilers translate the entire source code into machine code simultaneously, creating an independent executable file. Because this file no longer requires translation during runtime, the execution speed is significantly faster, making it ideal for the final release of a commercially distributed software." Boom. Do you see the difference? Examiners want to see your evidence-based reasoning step by step. Identify the elements, apply the principles, execute the analysis, and present it clearly. Show them the entire journey.
To show that journey, you have to master data interpretation, as outlined in this table. This is how you build the evidence and explanation parts of your Peel paragraphs. First, extraction. You need to confidently pull relevant data from the complex texts, scenarios, or tables the exam gives you. Second, interpretation. This is where you analyze the relationships. How does the slow, line-by-line execution speed of an interpreted code relate to the severe hardware constraints mentioned in the specific scenario? You have to connect those dots. Finally, conclusion. Draw evidence-based findings. Don't just give an unsubstantiated opinion. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. When you draw that final conclusion, base it entirely on the extracted data and your interpretation of the software's functional principles. If the scenario says memory is highly limited, your conclusion better mention how an interpreter might save memory compared to a bulky compiled executable. Moving right along to Section 3, the procedural framework. Okay, this 5-step sequence is your standardized, no-nonsense pathway to top marks. Let's make this interactive. Step 1 is deconstruct the question. You have to decode the command words. Are they asking you to describe, analyze, or evaluate? If it says evaluate and you just describe, you've already lost. Step 2 is extract relevant data. Let's do challenge 1, data scan. Imagine a complex data scenario on your screen right now about a team of global developers with a 60-second timer ticking down. Your job is to extract the core trend. The trend is that they need cross-platform compatibility and rapid debugging. Step 3, select your analytical framework. Based on that trend, are we looking at a performance framework or a development speed framework? For rapid debugging, we need an interpreter framework. Step 4 is execute. Let's do challenge 2, find the flaw. Listen to this sentence. Sam wrote, "The linker translates the source code faster so the team can debug." What's the flaw? You have 5 seconds. Right. A linker doesn't translate source code. It combines object files. Total terminology failure. Finally, step 5, present with correct terminology. Wrap it all up using the Peel structure we talked about earlier. Now let's level up. Section 4, mastering comparative analysis. This comparison slide right here brilliantly illustrates an area where examiners are practically begging candidates to improve. Comparative analysis absolutely requires you to identify similarities and differences. So many students almost instinctively only list the differences between a compiler and an interpreter. A compiler does this, but an interpreter does that. You must identify both. Both are translation software.
Both convert high-level language into machine code ultimately. You must link these concepts with comparative connectives, words like whereas, conversely, similarly, or on the other hand. Let's do challenge 3 right now, speed writing. If you had a 30-second timer on your screen, how would you write a perfect comparative Peel paragraph? You'd say, similarly, both a compiler and an interpreter translate high-level code so the CPU can execute it. However, whereas a compiler translates the entire batch prior to execution, an interpreter translates it line by line concurrently. You must support each point with evidence from the given scenario and then draw conclusions about why that specific difference actually matters for the company in the prompt.
Finally, the absolute pinnacle of exam strategy. Section 5, Evaluative Thinking for Top Marks.
This is where we finalize your system. To guarantee top marks, you have to follow 3 rules: command word decoding, Peel framework application, and a strict time management matrix. But the crucial point to elevate your analysis is evaluative thinking. You must identify limitations, explore alternative interpretations, and ruthlessly justify your decisions. Top-scoring candidates demonstrate this by questioning the underlying assumptions of a scenario. If an exam prompt assumes the linker is the primary bottleneck for a software's release, question that. Is it the linker, or is it the compilation time of a massive codebase? Evaluate the alternatives. What if they used a completely different development approach? Compare these approaches rigorously. And when you finally make a recommendation at the end of your essay, you must justify it heavily with evidence. You have to look at the limitations in the data provided, acknowledge them, and explain why your choice of system software is still the most logical path forward despite those limitations.
Look at this progression. Top-tier answers graduate from merely descriptive levels, move through analytical levels, and arrive all the way up at a fully evaluative framework. A descriptive answer, like Alex's initial attempt, just tells me what a compiler is. An analytical answer explains how the compiler interacts with the linker to resolve external library addresses and create an executable file. But an evaluative answer, that looks at the entire system context. It weighs the use of a compiler against an interpreter for the specific business problem presented, identifies hardware or time limitations in both approaches, and justifies a final strategic recommendation. That is the blockbuster journey your essay must take. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. So, as we wrap up this explainer, you have a choice to make. How will you use this systematic approach to dominate your next Cambridge IT exam? Will you just be like Alex, trying to blindly memorize textbook facts about compilers and linkers? Or will you apply this procedural evaluative framework to secure that massive 15% of your grade? The blueprint is entirely in your hands. Now it's time to build. Drop a comment below right now with your target grade for your next exam, and tell us the biggest challenge you're currently facing with system software questions. Our team responds to absolutely every comment. Make sure to like and share this explainer with a study partner who needs a wake-up call. Ace the Exams, your Cambridge success starts here. See you in the next one.